This is the 2013 November Statistics and Probability Calculator paper, higher tier. Okay, so if we look at question 1, Kerry wants to find out how many people spend watching rugby on television. She's going to carry out a survey using a questionnaire. Design a suitable questionnaire for Kerry. Okay, well the first thing we want to know is how much rugby people watch. However, we're thinking about, we want it to be as specific as possible, so we want to give some sort of time frame. So I would say, how much rugby do you watch in a week? So just how much rugby you watch is quite vague. Okay? Then you want to give people options, so it's really easy to work out. So, some people might watch no rugby. Some people might watch around 1 to 3 hours. And some people might watch 4 or more hours. Okay? So it's a 2-mark question. So, with regard to the mark scheme, you get your first mark for a question with a time frame. Okay? The second mark is for 3 boxes. So usually with these kind of questions, they want at least 3 boxes. They have to be non-overlapping. So that means if I did 1 to 4 hours here, I wouldn't know whether to put, if I watched 4 hours of rugby a week, a tick in this box or that box. They also should be exhaustive. That means all the options have to be covered. So if I just had 1 to 3 hours, 4+ hours, if I didn't watch any rugby, I wouldn't be able to put a tick in any box. So everyone needs to be able to answer the question. And the main point here is, there needs to be a unit of time somewhere. Okay, so I've given hours. Okay, that can be either in the boxes or in the question, so it could be how many hours of rugby do you watch in a week. Okay, but there needs to be a unit of time. So not how much rugby do you watch in a week, none, 1 to 3, 4+. That doesn't really make sense, does it? Alright, so if we move on to question part B. Okay, Kerry asked the girls in her class to do the questionnaire. Her sample is biased, and you have to give 2 reasons why. 2-mark question, again, helpfully. They've given us 1 and 2. So, there are a variety of different things you could say here. The first thing is, she's asking only girls. Okay, that's quite biased. Secondly, they're all in the same class, so they're going to be the same age. Okay, that's not great. It's not going to give us a wide range of people. Okay, they're also in the same year group. Again, we've got trends through different year groups, so rugby might be more popular one year than another, we don't know. Finally, we're looking at the same school, so they're going to likely think alike. Okay, there's loads of things you could say. These are probably the main ones. With regard to the mark scheme, each of these is worth 1 mark. So any 2 of them will get you those 2 marks, okay? So any 2 of these for your 2 marks there. Okay, let's have a look at question 2. So, Tim plays a game. He can win the game or lose the game, or he can draw. And it gives us the probability that he will win, 0.25. Probability he will lose is x. So we don't know what that is. Give an expression in terms of x for the probability he would draw the game. Okay, well, when we're dealing with probability, all the options have to sum to 1. So the probability he wins, plus the probability he loses, plus the probability he draws, has to sum to 1, okay? Because those are the options. They're mutually exclusive. So he can't win and lose at the same time. We know the probability he wins is 0.25. The probability he loses, we don't know, but they've told us that it's x, so you can fill that in, plus the probability he draws equals 1. Now it's a simple matter of giving an expression for the probability he draws the game. So, losers plus draws, well, if I take away 0.25 from both sides, I get 0.75, okay? So the probability that he will draw in terms of x is 0.75 minus x. So I've brought that x over to the other side by taking that away from both sides. Your first mark is for some sort of understanding of this, okay? So all of them sum to 1. 0.25 plus x plus draw equals 1. So some sort of expression like 1 minus 0.25 plus x, or 0.25 plus x will give you that first mark, okay? Your second mark is for this answer here. So I need this 0.75 minus x to get that answer mark there. If I look at part B, he plays the game 240 times. I want an estimate for the number of times he's going to win. Okay? Well, the probability of him winning, I've been told, is 0.25. Okay, if he's playing the game 40 times, we've got 0.25 times 40. Sorry, times 240, so he's playing it 240 times. It is a calculator paper, so you can type that in on your calculator, and you'll get an answer of 60. It's a 2-mark question. So for the mark scheme, if you look at the mark scheme, your first mark is for writing out that calculation. Okay, 0.25 times 240. Your second mark is for the actual answer of 60. Okay, so question 3, I've got the heights of 15 students and we've been asked to draw an ordered stem and leaf diagram for these heights. You must include a key. Okay, so the easiest way I think to draw a stem and leaf diagram is group these into categories. So here we're looking at categories of 10s, I think. So I start with 150, just because that's the closest, the first one, sorry. 150, 158, 156, 154, and 152. Okay? And I've got 163, 165, 161, 166, and 167. Okay? Then I've got 149 and 148, and then lastly 171, 170, 174. Okay, so I've got 15 students, so I should have 15 heights here. Quickly count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. Now I've done that, I can easily see my smallest is going to be 148. So I'm going to fill that in there, and then I can really easily now put them in the correct order down here. Then 150, 52, 4, 6, and 8, 161, 3, 5, 6, and 7, and lastly 170, 171, and 174. Okay? Questions told us not to forget a key, but they've also helpfully prepared this box for us. So 148 equals 148 centimetres, okay, because we're dealing with centimetres. With regard to the mark scheme, it's a 3-mark question. Your first mark you would get for having an unordered stem and leaf diagram. So if you filled these out with numbers, but they weren't in order, you'd still get 1 mark, okay? Your second mark is obviously having an ordered stem and leaf diagram. It has to be fully correct, obviously, because it has to be in order. You can minus 1 mark for each error. So if you missed one out or accidentally put one in the wrong order, we've obviously gone back to having an unordered stem and leaf diagram. Okay? And then your final mark is for that key. Okay? And here's a little tip for you. So if you just written 148 there, that's completely fine. I would always recommend you include your units, just in case the mark scheme decides to be really strict on it one year. Okay, work out the interquartile range. Well, to work out the interquartile range, we're going to need to find the median, and we can use that to find the lower quartile and the upper quartile. Okay, so as I've ordered them, it's going to be really easy for me to find my median now. So So my median is 161. Okay, now to find my lower quartile, okay, 152. And my upper quartile, so remember you don't include the median when you're finding these, 167. So my interquartile range is 167, take away 152, which is 15. Okay, it is a 2-mark question. So you get your first mark for working out the upper quartile and lower quartile. Okay, the second mark is for obviously the answer of 15. Okay, they've been quite generous here. They've said you can follow through, as long as they can see the method's correct, obviously, if the stem and leaf diagram's incorrect. Okay, so even if you didn't quite manage to get all those numbers in there, or you did it the wrong order for some reason, you can still get a follow through mark there. Okay, so question 4, we've got a graph converting between litres and gallons. We're given 2 different people, one who buys diesel in gallons, one who buys diesel in litres, and we want a comparison of price. So the first thing we need to do is convert all units to the same. So we want the cost per unit, okay? Whether that unit is litres or gallons, that is up to you. Okay, just because we've got 8 gallons there, I think I'm just going to pick that. So I'm going to choose to convert everything to litres, okay? 8 gallons looks like it's going to be 36 litres, okay? So 8 gallons is 36 litres, okay? So Jack, okay, for 36 litres, he paid £52. Okay, Francoise, 40 litres, for which he paid £58. Now I want to work out the cost per litre. So, 52 divided by 36, 1.4 recurring, and 58 divided by 40, 1.45. So Jack pays £1, so that's going to be 4444. So he pays £1.44 per litre, and Francoise pays £1.45 per litre. Okay, so the question's asking me who's got the better value for money. So obviously Jack got better value for money, so he's paying less per litre. Okay, with regard to the mark scheme, okay, your first mark is for using the graph, okay, to convert into the units and then finding out the per litre or per gallon cost. Okay, so I've chosen to convert to litres. If you chose to convert to gallons, that's fine. But the per litre or per gallon cost for one of those. Okay, your second mark is for getting both of those. So for getting 1.44 and 1.45. So you need to do that with both Jack and Francoise. Okay, and then your third mark is for obviously answering the question. So saying that Jack got better value for money. Okay, so I've obviously converted into litres. If you convert into gallons, that's fine. Okay, just in case you did, underneath, if you did the per gallon cost, you should have got, obviously Jack's already in gallons, so we've got 52 divided by 8, so we've got £6.50 per gallon. If we converted Francoise 40 litres into gallons, you should have got 58 gallons. That doesn't sound right. Sorry, you should have got 8.8 gallons, so you should have had 58 divided by 8.8, which would have given you 6.59 per gallon. Okay, and obviously she's still paying less. Okay, so that's just down there if you happen to convert to gallons. Okay, question 5. I've got a scatter graph. Information about the rainfall and the number of umbrellas sold in a shop for 8 months of the year. So, A. Describe the relationship between the rainfall and the number of umbrellas sold. So if I zoom out a little bit so we can maybe see. Okay, so it's only a 1 mark question, but there's actually 2 different things you could say. So if we look generally at the direction that we're going in, direction of the little points, okay, we can see we're going in that direction, which means there's a positive correlation. Okay, if you write that, that's perfectly fine, you're right, you can get 1 mark. Okay, however, you could have been more specific and you could have said, the greater the rainfall, the more umbrellas sold. That makes sense. Okay, but that's what the graph says as well. Okay, so it's only 1 mark, but either of those will get you the mark. Obviously, if you write both, that's great, be on the safe side, but you can't get 2 marks. If we look at part B, in a different month, the rainfall was 28 millimetres. Estimate the number of umbrellas sold that month. So the month's not actually on the graph, but I can use the graph to estimate it. And I do this by drawing a line of best fit. So the way I always try and draw lines of best fit, there's no exact science, but I try and get as many of these little crosses on or as close to the ruler as possible. So there I've got around 4. So I think I'm going to pick this one. Because there is no exact science, obviously, in the exam you will get a leeway, okay? So usually it'll probably be somewhere between here and here for your line of best fit, okay? So the rainfall is 28 millimetres in the month they want us to estimate for. Rainfall along here in millimetres. Each little square is worth 1 millimetre, so I've got 10 squares in between 20 and 30. 28 millimetres along here. So I draw a line up, okay, and then across. Oh. All right, so here you've got to be careful because each square isn't worth 1, because I've got 10 squares between 40 and 60, so each square is worth 2. So that's actually going to be 50 there, 54. Okay, so from my line of best fit, I think it's 54 millimetres. Okay, with regards to the mark scheme, your first mark is for drawing a line of best fit. Obviously, that has to be with a ruler. Okay, your second mark, not everyone's going to have drawn the same line of best fit. So anywhere between 52 and 60 millimetres, as long as they can see you've correctly read off that point there, 28, and read up and across, you'll get that answer mark there. Okay, so question 6. We've got loads of information here. I'm not going to read it all out, but essentially we've got a family going to New York. There's 2 different airlines they could use. They obviously want to buy the cheapest ticket they can. Okay, so let's have a look at the information. Firstly, they're thinking about going to New York on the 3rd of August. Okay, they're going to buy 2 adult tickets and 1 child ticket. And here we've got the information given about various discounts. Okay, so they want to go on the 3rd of August. So that is going to be in this category here. Okay, so let's take a look at the actual breakdown of costs. Zoom in a little bit. Okay, so if they fly with Highway Airlines, 1 adult is going to cost £462 and a child costs £251. So we've got 1 adult, oh, if I can spell, 2 adults is going to be double that, so 462 times 2, 924. 1 child is 251, so 924 plus 251 equals £1,175. Okay, but that's not the actual cost, because remember we've got various discounts here. So a total of 5%, okay, is going to be discounted with Highway Airlines. So I need to work out, if I've got this is 100%, a 5% discount, I'm going to do a 5% decrease, 95%. So the total cost is going to be 95% of 1,175. Okay, the way I always do this is, I'm going to go back down to 1% and work my way back up to 100%. So if 100% equals 1,175, 1%, well, divide by 100, so it's going to be £11.75. I want to work my way back up to 95, so I need to times that by 95, which is going to give me £1,116.25. So that's the total cost for Highway. Okay. If they fly with Jetstream, oh, can't spell. 1 adult is £485. Okay, so 2 adults is going to be double that, which is 970. add on the child, which is £218, which is going to be 1,188. Again, I've got a discount. I've got a discount of £25 per person. Well, I've got 3 people here. Okay, so I've got 2 adults and 1 child. So £25 times 3 is going to be £75. So the total cost for Jetstream Airlines is going to be 1,188, take away 75, which gives me £1,113. Sorry. So if I compare those two costs, excuse me. Okay, Jetstream's obviously cheaper. I make a £3.25 saving. So I need to actually answer that question. Which airline should they choose? So they should choose Jetstream. Okay? So there's quite a lot of marks available for picking up here. So let's have a look at the mark scheme. So we get the first mark for identifying the correct cost from the table. Okay? So just by picking out the right dates here and using those prices, you get 1 mark. Okay? Your second mark is for the total cost for the family before the discount. So for working out either this one or this one, that gets you your second mark. Okay? Your third mark is for calculating the discount for either company. So obviously, either this one, okay, or this final one there. So the other way you could have done that is obviously working out 5% and subtracting it. So if you worked out that 5%, that would have got you the mark, either the 75 or that. Okay? And then you would get 1 answer mark for both this 1,116.25 and the 1,113. So you do need both of those in order to get that answer mark. Okay? And then the final mark is for answering the question that they should choose Jetstream. So, to make it really clear, I'll try and write it underneath for you. First mark, identifying the correct costs from the table. Okay? The second mark is for the total cost of the family before either discount's been applied. Okay? Your third mark would be for calculating the discount for either, okay, Jetstream or Highways. Your fourth mark is for that £1,116.25 and £1,113. So you need both of those for that answer mark. Okay, and your final mark is for correct answer. So saying Jetstream. Okay, so hopefully that was all clear. Okay, so question 7. Chelsea's height is 168 centimetres to the nearest centimetres. Okay, so it's been rounded. What is her minimum possible height? What's her maximum possible height? So we're thinking about bounds here. So if I've got 168 centimetres, the way I always think about this is the length of the bound is what I'm rounding to. I'm rounding to the nearest centimetre, okay? It's going to be plus or minus half of that on each side. Okay? So you're looking at 167.5. Sorry, the light has just gone. Okay? And 168.5. That's a 1 centimetre bound there. So her minimum possible height is going to be 167.5 centimetres. Okay? It's just 1 mark, so you just need to get that right in order to have that mark, okay? You don't need to show any working, obviously it helps if you do. What's her maximum possible height? So with this one, 168.5, again, will get you that mark. But you can have 168.49 as well. Okay, so if you're not happy with 168.5, because obviously that one rounds up, we can have 168.499 and so on. Okay? So, question 8. We've got Alice as a lorry driver, the distance of 40 trips, and we've got information about these distances. We want an estimate for the mean distance. Obviously, the mean's going to be an estimate because we're dealing with group data, so we're not going to get it exact. So, the mean is the sum of the frequency times the midpoint divided by the sum of the frequency, okay? So, first thing is I need to pick a midpoint because I'm dealing with group data. So I'm going to have 425, 475, 525, 575, okay? So that's going to be my x. Now I'm going to do f of x, so frequency times midpoint. So 9 times 425, 15 times 475, 12 times 525, and 4 times 575. Okay. With regards to this formula, I need to do the sum of all of those. So I need to add them all up. So 3,825 plus 7,125 plus 6,300 plus 2,300. Okay, which gives me 19,550. Okay, the sum of the frequency will be all of these added up. You can add them up if you want to, okay, but actually the question already tells us she does 40 trips, so that you should already know the frequency is 40 without having to add those up. So, 19,555 divided by 40. So that gives us 488.75. Okay, so the mean distance is going to be 488.75 miles. Okay. If that didn't round to 2 decimal places, just went on forever, I would suggest you round it to 2 decimal places, unless the question specified something different. With regards to the mark scheme, your first mark is for doing a consistent frequency times something within the interval. So if, for example, you didn't pick the midpoints, okay, you picked another number within the interval, so you picked 400, 450, 500, 550, so you consistently picked the beginning of the bound, or if you picked the end of the interval, 455 each time, that would be okay, as long as it's consistent, so you can't pick 400, 500, 500 again, for example. That obviously wouldn't make any sense. Okay, your second mark is for choosing the correct midpoints. To do that, f times x, okay? And then your third mark is for doing the sum of f times x, and that can be a follow through if you got that first mark with the consistency but didn't pick the correct midpoints, divided by the sum of the frequency, which is 40, okay? And then your final mark is obviously for the answer. So if you rounded that to 489, that's fine if you got rid of those 2 decimal places. Surprisingly, 488 still gets you a mark as well, even though it's incorrectly rounded, but there you go. Okay, question 9. We've got the number of lemons, 60 lemon trees, an incomplete table and box plot, give the information, so you've got to use the information to fill in the gaps. All right, so let's have a look at this. So this is the end of my whisker. That's going to be the smallest number of lemons, okay? Here I've got 10 squares to 5, so each square is worth 0.5. So if that's the middle, it's 2.5, that's going to be plus 0.5, so I can fill in the smallest number of lemons as 3, okay? Here I've got the median is 11, so I can fill that in with a line in the middle, 10, 10.5, 11, here, okay? Upper quartile, I don't know from here, but on here I've got it as 17, because that's 17.5, okay? Then I can finish off that last whisker by filling in the greatest number as 22. So we're looking at a line along here, just before that 22.5 halfway point. Okay, so with regards to the mark scheme, you get 3 marks for this. So your first mark, you had 1, 2, 3, 4 bits of information to fill in, so you get 1 mark for 2 out of 4. Your second mark is for if you got 3 out of 4, and then your final mark is for obviously all 4 correct. Okay, so it doesn't matter which ones, as long as you get some of them right. okay, you get those marks. Okay, so let's take a look at question B. Some of the 60 lemon trees have 8 or more lemons on them. Find an estimate for the number of lemons with 8 or more lemons on them. Okay, well, if we look back at our table, 8's our lower quartile, okay? Lower quartile, if the median is 0.5, the lower quartile is 0.25. Okay, but I don't want the lower quartile up to the lower quartile, which is 0.25. I want 1 take away the lower quartile, okay, because the lower quartile is 8. So I need to do 0.75 times 60. So I'm looking at 60 trees, okay? If I type that in on the calculator. Okay, so with regard to the mark scheme, your first mark is for realising the lower quartile is 0.25, which is 8. I don't want up to that point, I want more than that, so it's got to be 75 rather than 0.25, as we've got 60 trees times by 60. Your second mark is for that answer, okay? And this is a correct answer only question. So if you just write 45 without this working, 0.75 times 60, you would only get 1 mark. Okay, so question 10. We've got information about 80 children taking to a jigsaw puzzle. We want to work out the mean time for 80 children. So, to work out, we've been given here the mean time for each boy. We want 32 of those boys. So I need to do 32 times 32.4. 1036.8. Okay, got 48 girls, each of them 28.4. So for all the girls, 1363.2. So for all 80 children, the total time of those two added together, which is 2,400. Okay, I've got 80 children. This is the total. So I need to do 2,400 divided by 80 to work out the mean time for all of them. Okay, so I've combined the boys and girls. Now I need to go back down to work out the mean time, regardless of whether you're a boy or a girl. That gives me 30. So the mean time is going to be 30 minutes. With regard to the mark scheme, working out either of these, say the length of all the boys or all the girls, okay, gives you 1 mark. Okay, your second mark is for doing that calculation there. Okay, and then the final mark is for that answer of 30. Okay. So question 11, I've got a cumulative frequency graph about the heights of 2 groups of children, A and B, and we've been told to compare the heights of children in group A and in group B. It's a 2-mark question. Okay? So, with this one, they want, the mark scheme says they want a summary of data with, and this is the important bit, correct numerical values. Okay, and you've got to do that 2 times. So, if we're looking at cumulative frequency, the easiest thing you can be thinking about are your medians and your interquartile ranges. Okay, so let's have a look. Well, the median, we've got 100 children in each group. So the median is going to be the 50th child. Okay, if I go along this side for the frequency, each square is worth 2 children, because I've got 10 squares between 40 and 60. I can draw a line across, okay, and draw 2 lines down. Okay, so if I'm looking along the bottom now for the height, each square is now worth 0.5, because I've got 10 squares here, which is a value of 5. So my median for group B is going to be 2.5 centimetres. My median for group A is 150, let's say 156.5. Okay? So, well, the first data comparison I can have then, to do with the medians, is that the median height of children in group B is, and I need the correct numerical value, is 162.5 centimetres, which is taller than median child in group A, as they are 156.5 centimetres. Okay? So that would get you your first mark. So we've got correct numerical values in there, and we've compared them. Your second mark, well, let's have a think about the interquartile range. So the interquartile range is going to be the lowest quartile, which is the lowest quarter. If I'm dealing with 100, that's going to be 25. Okay, remember I'm going up in twos, so 2 for halfway along this line here. And 75, which is going to be 70s here, so 2, 4, 5. Okay, so if I draw these lines down now, so the upper quartile for group B is going to be 164.5, that looks like. And for group A, we're looking at 159.5. Okay. The lower quartile, I'll do this in a different colour so it's a bit clearer. For group A, that looks like 151 to 153.5. And for group, interestingly, the same, 159.5. Okay, so again, I need to write something about all of that down here. So I run out of room just because I've written that up there, but let's see. Well, the interquartile range for group A, I've got 159.5 take away 153.5, which is 6 centimetres. Okay, for group B, I've got 164.5 take away 159.5, which is going to be, I'll just check on a calculator, 5 centimetres. Okay, so you can say the interquartile range for group A is larger at 6 centimetres compared to group B, which has interquartile range of 5 centimetres. Okay, so I've done the interquartile range. You probably could have got away with comparing the upper quartile and the lower quartiles, but that would have been less certain to get you your mark. So it seems like quite a lot to do there for a 2-mark question, but to be on the safe side, the maths itself isn't that hard. It just requires you to make sure you're able to read off this graph correctly. The key point here is we need the summary of data with correct numerical values, and you need to do 2 of those. Okay, so question 12. I've got a graph showing information about the speeds of 2 different cars. Okay, and we're asked to work out the gradient for car A. Alright, so remember, gradient means the steepness of the line. Okay? To calculate that, my method's going to be the change in y, so the change in the height divided by the change in x, change in going across. So we want to draw a little triangle. It doesn't really matter where you draw the triangle. I think it's easiest for me to start here because that's where it starts, and then I can go across and find a point where it goes exactly to the end of that little square. Okay? If I look at this graph, each little square across represents 1, so that's going to be 11 seconds across. If I'm going up, each square represents 0.5, so that's 3 squares up. Okay? So change in y, 3, divided by change in x, 11. Okay? So you could have done that at any point along the line. 3 divided by 11 is 0.2727, so on. So I think I'm going to round that to 0.27. Okay? It's a 2-mark question. If we look at the mark scheme, your first mark is for some sort of method. Okay? So I've done 3 divided by 11. You could have done that at any point along the line. Your second mark is for the answer. Here, they're going to give you the mark as long as you get somewhere between the range of 0.27 and 0.29. Okay? After how many seconds, is the speed of the car of A equal to the speed of car of B? Well, that's obviously going to be where these two lines cross, because that's when they're equal. Okay? After how many seconds? Well, I can use the graph and go down to how many seconds. Okay? Looks like, now I've done it with quite a thick pen, but that's going to be 35, and we're just over that, but we haven't quite got to 36, so something like 35.5 might be sensible. Okay? So, this is only a 1-mark question, but they've actually been very strict with it. So I've said 35.5 seconds. Okay, you need to look for where the lines cross. As it's only 1 mark, you only get a mark if you've got the correct answer. Unfortunately, if you decided to think it didn't really matter too much and you put down 35, you would not have got that mark. You need to recognise that the lines cross past 35 seconds, but they haven't quite got to 36 seconds yet. Okay, so be really careful about that. Always try and be as accurate as you can. You would get a mark for somewhere in the range of 35.1 to 35.9 seconds. Okay, so question 13, we've got a probability question. A and B are independent events. The probability A will happen is 0.3, probability B will happen is 0.6, and we're asked to complete the probability tree diagram. Okay, so the probability A will happen, 0.3, they fill that in. We've got independent events, okay, so these are two separate events. On a probability tree, your branches need to add up to 1, okay, so that's going to be 0.7, as we've got 1, take away 0.3, 0.7. So the probability event A doesn't happen is 0.7. Event B, 0.6, probability that it will happen. Again, we need to take away from 1. The probability it will not happen is going to be 0.4, okay? And as they're independent events, I can fill those same 2 out down here, okay? So that's a 2-mark question. Your first mark would be for filling out either 0.7 or one of the 0.4s, okay? So either of those will get you your first mark, okay? If it's fully correct, you get those 2 marks, okay? So just filling out that gives you 1 mark, just filling out that, 0.4 would give you 1 mark. Filling out all of this, but not the 0.7, still gives you only 1 mark, so you need all of that correct to get those 2 marks. If we move down to part B, okay, work out the probability that either event A will happen or event B will not happen. So we need to look back at our probability tree diagram. So event A will happen, we're going to be going along here, okay, and then event B will happen, but not B. So that must mean if event A happens, event B will not happen, okay, and then if event A doesn't happen, then event B has to happen. Okay, so I'm looking at the probability of event A happening times the probability of B not happening is going to be 0.3 times 0.4, which is going to give me 0.12. The probability that event B happens, but that must mean A does not happen, is going to be 0.7 times 0.6, which is going to give me 0.42. Okay? As it's an either question, I need to add those 2 together. Oh, can't add. 5, 4. Okay? So, with regard to your mark scheme, your first mark is going to be for either one of these 2, okay? So either one of those 2 calculations. And then your second mark is that answer mark for 0.54, okay? With this question, depending on what you've done in your tree diagram, as long as you follow the route that it will happen, will not happen, will not happen, will happen, okay? Regardless of whatever numbers you've put on there, you can still pick up 2 marks, okay? There's follow-through marks. as long as it's obviously clear that you've picked the right branches of the probability tree. Okay, question 14. I've got 150 students who went to London, and we've got a table giving us information about where they visited and whether the student was male or female. Kate takes a sample of 30 of these students. It's a stratified sample, okay? So remember that stratified means proportional. And we're being asked to work out the number of male students who visited the stock exchange in the sample. Okay, so, well, if it's a stratified sample and it's proportional, okay, we've got 35 male students who visited the stock exchange, so we want 35 out of the total number of students, which is 156. Okay, and then we want to multiply that by the total sample size of how many students Kate is taking. So you can just type this in on your calculator, 35 divided by 136 times by 30. Okay, we've got a decimal number here. Just check my answer. Okay, we've got a decimal answer here. Yeah, I thought I typed something in wrong. Okay. So, obviously, we want the number of male students who visited the stock exchange in the sample. I can't really have 0.7, 6.7 people. Okay, so I'm going to choose to round that up to 7 males in the sample. Okay, this is only a 2-mark question with regard to the mark scheme. Your first mark is for that method there. Okay, and your second mark is for an answer. As they've given us a bit of a naughty answer that comes out as a decimal, okay, anywhere between 6 and 7 would get you a mark. So if you chose to round that down to 6, that's completely fine. Okay, so question 15, we've got the time that some people took to run a race and a histogram that records these results. Okay, we've been given the information. 25% of the people took a time less than t minutes. Work out an estimate for t. So, there's various ways you could do this question. What makes the most sense for me is a histogram, obviously. Each square represents, in this case, a person or a number of people that ran this race. That's what frequency density is all about. So, it makes sense to me to count the squares and then use that to work out an estimate for t. So, if I look along the bottom here, each square is worth 0.5 because I've got 10 squares between 50 and 55. Okay, here I've got 1, 2, 3, 4, 5 squares going across, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18 squares going up. Okay, so I've got a total of 90 squares. This one I've got 10 squares going across the bottom, and 10, 20, 30, 5 squares, 35 squares going up, so I've got 350 squares. This one I've got, let's see, 2, 4, 6, 7 squares along the bottom, okay, and 10, 20 squares along the top, so 140 squares. This one I've got 2, 4, 6, 8, 10, 15 squares along the bottom and 12 squares along the top, which is 15 times 12, 180 squares, okay, and this last one I've got 7 squares along the bottom, 5 squares up, so 35 squares, okay. So, if I add all of those up, 90 plus 350 plus 140 plus 180 plus 35, I'm going to end up with 795 squares in total. Okay, so I want 25% of those. So 25% as a decimal, okay, is 0.25. So I want 795 times 0.25, 198.75. That represents 25% of squares. So I need to find that square in my histogram. So I want the 198.75 fifth square. I've got 90 squares here, okay, and I've got 350 squares here. So if I think about going along each minute, 90, each column here contains 35 squares. So if I write something down here to help me, from 51.5 minutes to 54 minutes, I have 90 squares, okay? That means I've got 108.75 squares to go. As in my 54 minutes to 58 minute section, I've got 350 squares. I know it's going to be somewhere in this range of time, okay? If we think about columns, like I've just said, I've got 35, okay? So that's going to, another 35 will bring me to 70, and another 35 brings me to 105.5. So I want that fourth square, that fourth column, across, okay? That looks like 56 minutes to me, okay? Obviously, it's somewhere in the range of 55.5 to 56, because I haven't quite got all the way, okay, to that is not exactly 108.75 if I go down that column entirely, okay? So, another way you could have done that without doing it visually is thinking about 108.75 divided by 35, which is how many squares are in each column, which tells you that it's going to be the third, as I've got 3.11, the third and a bit column across, okay? So if I'm 3 columns into 54, and each one is worth 0.5, okay, I know it's going to be somewhere in that range of 55.5 to 56 column, okay? So I'm going to choose to round that up to 56 minutes, okay? This is all quite complicated, but if you break it down, it does make sense. So, with regard to the mark scheme, your first mark comes to working out that 25% of those squares, okay? You might have done it a different method, but this is the way I think is quite easy to explain, okay? Your second mark would be for counting across the number of rows, or doing this to figure out how many columns into that 54 to 58 minute section you're in, okay? And obviously your third mark is for your answer. So here, as it is quite a complicated question and we're not exactly on 56 minutes, anywhere in the range of 55 to 56 minutes would get you that answer mark. Okay, so question 16. We've got 11 girls and 8 boys in a tennis club. Jake is going to pick at random a team from the tennis club. It will have 2 players. Work out the probability he will pick 2 boys or 2 girls for the team. So, with the probability questions, the first thing I'm going to do is think about drawing a probability tree to represent all of Jake's option. So he's going to pick 2 players, player 1. So you could pick a girl for player 1. Okay. There are 11 girls and 8 boys in a tennis club. There are 19 children in total. Okay, because 11 add 8 is 19. So my probability is going to be out of 19. There are 11 girls and 8 boys. Okay? For player 2, you need to be very careful here. So, if he's already picked a girl for player 1, there's only going to be 10 girls left. Okay? And we've only obviously got a choice from 18 rather than 19 now, as we've already picked one person out. There's still going to be 8 boys, there's just going to be 1 less person in total. Okay? If we picked a boy for player 1, we're going to have still 11 girls, again out of 18. And we're going to have 1 less boy, so 7 out of 18. Okay, so be really careful about that bit there, because they're trying to trip you up. Okay, so work out the probability he will pick 2 boys. So that would be that route, or 2 girls. So, probability, he's going to pick 2 girls. 2 girls. It's going to be 11 over 19 times 10 over 18, which is and I'm going to leave that as a fraction for now. Okay, and that's a little tip for you just to make it all the more accurate. The probability that he's going to pick 2 boys is 8 over 19 times 7 over 18. Okay. I want the probability that either of these happen, so I need to add those up. And this is why I've left it as a fraction, because it's going to be easier and more accurate for me to add these up. The denominator is the same, so I can just do 55, add 28. Now I can convert that to a decimal. I end up with 0.485, so on. So if I rounded it to 2 decimal places, that would be 0.49. Okay? So, with regards to the mark scheme, okay, your first mark is for realising that this here is going to be out of 18 players, okay? So your first mark is for the second denominator as 18, okay? Your second mark is for doing either of these calculations, okay? So either one of these is your second mark, and you do need the answer included in that as well. Okay? Your third mark is for doing the addition of those 2 fractions. Okay? And your final mark is for the answer there. Okay? So if you'd written that down, that would be perfectly fine as an answer. If you did choose to convert it to a decimal, that's also fine, but you could have left it as that fraction there. Okay, question 17. We've got Clive. He wants to estimate the number of bees in a beehive. He captures 50 bees, he marks them with dye, he lets them go. The next day he captures 40 bees, and he finds 8 of them have been marked with dye, so what he did yesterday. Okay, so we're given this information. Using this, we have to find an estimate for the number of bees in the beehive. So, the easiest way I can think about this is, the first day he catches 50 bees, out of an unknown number. We can call that n. N can represent the total number of bees. Okay? So we don't know what that is. The first day he catches 50 bees out of n. Okay? And we can say these are the bees that have been marked with dye. On the second day he catches 40 bees. 8 of them have been marked with dye. So the number of bees marked with dye on the first day is 50 out of an unknown, the total. On the second day is equal to 8 out of 40. Okay? So now, to find what n is, I'm going to need to rearrange this. So, if I think about it, well, firstly, 8 out of 40 I can cancel down to 1 over 5, which is 0.2. Okay? So then I've got 50 over n equals 0.2. Now this is divide by n. I want to bring that n up onto the other side. So 50 equals 0.2n. Now I can divide both sides by 0.2 to cancel that out. So 50 divided by 0.2 is going to give me 250. So I've estimated that there are 250 bees in total in the hive. Okay? With regard to the mark scheme, your first mark is for figuring out how many bees have been dyed. So for writing that first step out. Your second mark is for some sort of calculation down here. Okay, so following through these steps, for your method, you get another mark. The final mark is obviously for that answer. Okay, 250. And again, this is a correct answer only. So if you manage to do all this in your calculator, or just guess 250 without any working, you'd only get 1 mark. Okay, and finally, let's take a look at question B. Write down any assumptions you have made. Okay, so, well, you could have said, you've made an assumption that there's a fixed population of bees. So for some reason, maybe on the second day, some bees died, or some new bees were born, okay? Or some bees have moved to another hive, okay? The second assumption you could have made is that he's taken a random sample. We're assuming he's taken a random sample, but he might have taken a biased sample. We don't know without more information. Okay? This part 2 is only worth 1 mark, so either of these will get you that 1 mark. Okay? You don't need to write down both.